Get started. So I just want to review the chain rule that we went over last week. And the chain rule is, hold on, I wrote this wrong. This should be here. So the chain rule is if you have something happening to this whole function, it's being cubed, but inside this function, there's this other function of x. So the chain rule says that you multiply f of x times the derivative of x. So you take the, one second. Sorry, I don't know if I said that before. It's you take the derivative of the outside, so I'll just put d of the outside, and times that by the derivative of the inside. So that's going to be your chain rule. Please ignore what I said before that. So what you're going to do here is you're going to take the derivative of the outside. So we're going to pretend that this is just some thing right here. It's like it's just a variable, let's just pretend in our heads. And that's why you could use u, and that would be substitution. And then you would take the derivative of the outside. So that means I multiply, and then I have 4x squared plus x. Then I minus 1, and that's right here. That's just using the product rule. And then, I'm sorry, the power rule. And then I'm going to go ahead and I'm going to take the derivative of the inside. So 2 times 4 is 8. Take away 1 for the power rule, plus the derivative of x is 1. And that'll be my answer here. So we're going to be using something called implicit differentiation. And you use this when you have, it's mostly if it's difficult to get all your variables or one of your variables isolated. So an example would be if you have, hold on. If we have something like this, it's kind of hard to get y alone if I wanted you to take the derivative. And you probably could, but it gets messy. Sometimes it's pretty much impossible to get it done. But it's when you have x's and y's on the same side and you're having a hard time getting the y alone, your f of x. So explicit differentiation is what we've been doing. So this is implicit. Before, the past couple of weeks, we've been doing explicit differentiation. So, and that's pretty straightforward. Something like y is equal to x squared plus 4x plus 24. See, we have the y alone, and then we have all the x's on the other side. But in this case, let me just erase it. For implicit differentiation, the reason I'm using it is because I have these twisted up and tangled x's and y's all together on the same side. And it's just going to be a lot trying to get the y alone. And to use implicit differentiation, I'll start with an example. There's some steps that you kind of want to remember. I don't know why that keeps happening with my pen today. So here are your steps. The first thing you're going to do is they're going to ask you to take the derivative with respect to x in these examples. And later you'll be doing the derivative with respect to time, or you just have to see what they want the derivative with respect to. And in this case, we're going to be asking for dy dx, okay? So you're going to differentiate any x you see like normal. Don't forget your power rule because it's going to come in a lot. You're going to be multiplying things. Not in this one, but you will be. If you have to differentiate y, then you do it and then multiply by dy dx. All right, so let's go ahead and do this. Actually, let me start with another example. That was just an example of when you would use it. And because I want to start easier. And I want another color. I'm tired of that one. So let's make this number 1. I know the other one said it, but you can just x to the third plus y to the third is equal to 8. All right, and I said find dy dx. And this is what we're looking at, the bottom. It tells you what you do normal, okay? And that means I'm just gonna take the power rule here, as usual. I'll have 3x squared plus, and then in this case, I'm gonna do the same thing with y, use the power rule. I'll have 3y squared, but now I gotta do this step, which is multiply by dy dx. And I'll give you a reason why in a second. And when you do this, you're taking that of both sides. So that means I also have to find the derivative with respect to x of 8. And that'll give me 0. Now the next step is use algebra to solve for dy dx. So treat this in your brain like it's, I don't know, like it's a variable, all right? And you're gonna solve for it just like it was a letter. And you're gonna do what you would always do in algebra. If I wanted to get this alone, I would first subtract 3x from both sides, or 3x squared from both sides. And that would give me 3y squared dy dx is equal to negative 3x squared. But then I still want to get this alone, and this is being times. So I'm going to do the opposite, which is divide both sides by 3y squared. And that would leave me now, this would cancel. So would the 3's, and I have dy dx is equal to negative x squared over y squared. And that's how you solve for dy dx. You might want to pause this and make sure you got all the notes down. So I just want to give you a quick reason so that you understand what we're doing. I could have written this, y is always f of x, right? And this is x, period, we know that. So I could have written this as x to the third plus f of x to the third, and equals 8. And that shows you where we have this composite function and why we use the chain rule. So we use the chain rule, which said 3, you would come in, let's just take this part. So we said y to the third is equal to f of x to the third. And I would take, what I'm saying here is, if I was to write this like that, I'm going to use the chain rule. That means I'm going to multiply here. So I'd have 3 times f of x, and then I'd have it to the second power. And then I would take the derivative of the inside. So that's where you're getting the whole, you have to multiply the dy dx to find it. All right, let's do another example. Find dy dx, then find the slope of the tangent line at the point negative 2, 1 of this 2x squared minus 3y equals 5. All right, so here we go again. It wants the derivative. So you're going to have to find the derivative. And the reason you use, to find the tangent or the slope of the tangent, you got to use the derivative. That's one of many things we're going to be using the derivative for. So we use the derivative to find the slope of the tangent. So make sure that you know this on all your tests. The first thing you do is you notice it's going to be too much. I'll have y cubed, I'll have this cube root. It's better just to leave everything written. Maybe what this means, your input value is here, and then here y is just a function of x. So it's not solved for y, so we'll use implicit differentiation. So the first thing I'll do is I'm finding dy dx, so I always look down here at the bottom to make sure which one I leave alone. That's going to give me 4x squared minus, now this, y is being written as an f of x. So that means I got to use the chain rule. Well, actually, here I'm using the power rule, and then I'm going to go inside and do dy dx. So that means I'm going to take the derivative of the outside, which is 9y to the squared, but I still need to take the derivative of the inside. So sometimes they'll write y prime instead of dy dx because it's easier, but that looks like y to the first. I don't mess with that. Plus, every time I write dy dx, I feel like I understand it even better. So I'm going to write dy dx, and then the derivative of 5 is 0. Now, from here, I got to get dy dx alone. So that means I'm going to have negative 9y squared dy dx is equal to negative 4x squared. Then I'm just going to divide by negative 9y squared to get this alone, dy dx alone. And now with these two negatives, this is a positive. And now that's dy dx. That's what dy dx is now. So I can go ahead and plug in these values for x and y. So the slope of the tangent line at that point, I think this looks something like this, I think. And then we've got this point where it's going to cross, oops, sorry, like that, and that's negative 2, 1. Okay, looks something like that. So what I'm going to do is I need to find the slope. What is the slope there of this tangent line as it hits this value or that coordinate point? So that's going to mean I plug them in because this is, okay, so now this is x, so that's going to be 4 times negative 2 squared all over 9 times 1 squared. That's 4 times 4. So your slope at that point, I think I did something wrong. Hold on. Oh, right here. I made a mistake here. This should be to the first power. This should be to the first power. This should be the first power. Okay, that makes sense now. All right, so that means that after I do all that work, please go back and notice I didn't minus my 1 here. And that would be negative 8/9 is your slope of the tangent line. At that point, negative 2, 1. All right, let's go ahead and do another example. Please take the time to go back and change your notes. I should have minused 1 when I was using the power rule. So let me just talk about some different ways that, or different moments, and you can decide if we're going to use the derivative, the implicit differentiation or not. So remember, it's when there is a variable that's different than the input variable. Okay, so we use implicit differentiation. When there's another variable other than the input variable. And that's on the same side of the equation. And I better just put it just so you know. All right, so let's just look really quickly. This is, you don't even have to write down, it's just for you guys to look at. I have the derivative with respect to x of y to the third. So what I would do is I'd look at this. This is not, x is the input variable. They want the derivative of y to the third with respect to x. So in this case, you're going to have to use the chain rule with implicit differentiation, and that's going to give you 3y squared. Okay, so I'm taking the outside of the y, but the inside of this is really an f of x. So I have to get the derivative of f of x, but I don't know what it is. So they'll write y prime, but I don't like y prime again because that looks like y to the first. So then I just write dy dx. And that's all you do. So if I said this one here, take the derivative with respect to time, you're going to be seeing that soon, of 2t to the fifth. Time is going to be a big deal in your related rates problems coming up. So here, there's a match. So I just got to do it regular. What if I had the derivative with respect to time, and I was going to wanted to know the change in height with respect to time, or something with an h, let's say. That doesn't look like a t. Well, I have a variable other than the input variable we're being in respect to. So I'm going to have to do more than just take the derivative like I did here. So that means this is going to be 10h, whoops, not to the sixth, 10h to the fourth. And now I'm going to write dh, the derivative of h, with respect to t for the inside part. All right, let's do more complicated problems with product rule attached to it. What is this number? I don't know. I'll call it number 3. Suppose I want the derivative with respect to x of this here, x to the third plus y to the third is equal to xy. You see how it's just going to be too hard to get y alone. So we use implicit differentiation. But I want you to take note here. Don't forget the product rules. It always creeps up on me, and I end up having to go back and redo the problem. So make sure, look, there's a product there of 2 numbers. So you're going to use the product rule. So in this case, it's with respect to x. So you make x as usual, but then you're going to take the derivative of 3y and get 3y squared, and then times it by dy dx. It just becomes almost like you just memorized to times the other one by dy dx. Now, what's the product rule? It says that you'll take the derivative of each one and add them. So in this case, I'm going to have, I'll take the derivative and I'll get 1y, because the derivative of x is just 1y. And then I'll multiply it. So you take the derivative of the first, times it by the other one, or the second. Then you add and you leave the first alone, times it by the derivative of the other side. So that's going to be leave this alone. The derivative of y to the first is just 1, but I still have to take dy dx because that's not, I'm taking the derivative with respect to x. So then that's just going to give me 3y squared dy dx minus, yeah, let's put this over here. I'm just going to put the dy dx's on one side, and I'm going to move the non-dy dx's to this side. So that's going to be minus 1 dy dx is equal to, I'm going to move this over here to this side. So that's going to be is equal to y minus, because I left this here, minus 3x squared. And then you got to go to the next step. An idea. All right, so let's just go ahead and continue here. This is, okay, good. So when you have two terms of dy dx's, see, we've been just having one and it's been easy. You do this special trick, is factor out dy dx. So notice we have dy dx and then dy dx again. The past couple examples, you only had to move like by minusing 3x squared or something. So here you're going to go, all right, I'm going to factor out a dy dx. And that's going to leave me with 3y squared minus 1 is equal to, and I should have dy dx here too. No, I shouldn't. Oh yeah, is equal to y minus 3x squared. Now, if I wanted to get, because I'm timesing, if I wanted to get this alone, then I would just divide both sides by 3y squared minus 1, and then this becomes my answer. Right here. I'll just write it, but your answer is dy dx is equal to y minus 3x squared all over 3y squared minus 1. Ugh, I don't like that box. I'll just leave it. But I like to, when you guys do put a box around your answers in your notes. All right, so that would be dy dx. And that's because you had to use the product rule and you did use the implicit differentiation with the chain rule. All right, I'm going to do a couple more examples. If you feel like you've got it, you could just move on. If you want to watch some more examples, that's good too. I'm going to say, let's find dy dx. Actually, you might want to stay for this one because it's going to be, let me find it. I'll do it now. I'll do it with tangents and I mean trigonometry. So sine dy dx of sine x minus x squared y plus y is equal to 10x. So look, big deal here. You got to know this. You're timesing, so you're going to use the product rule. So you take the derivative with respect to x of the first one. The derivative of sine x, you should already have memorized, is cosine x minus, now you're going to take the derivative, you're going to use the product rule, which is First, leave the first alone, then take the derivative of the other one, and make sure you put parentheses here. I always try and do that, so I make sure I know where this minus is going to go across. So this is going to give me x squared, and then I'll take the derivative, because I leave this alone, times the derivative of this, so that's going to be 1y. I'm sorry, just 1, because 1 minus 1 is 0, and then I have dy dx plus 2xy, because now I took the derivative of this one and left this one alone, plus, and then this is going to be 1, but I also have to take dy dx, is equal to, and the derivative of this is just going to be 10, because 1 times 10 is 10, 1 minus 1 is 0, so that's really just 10 times 1. All right, so then now you have to get dy alone, dx dy alone. I'm sorry, dy dx alone. Oh, I said that wrong, but okay, so that means, first I'm just gonna slam out that minus, and I have minus x squared dy dx minus 2xy plus dy dx is equal to 10. So I want to move all the non-dy dx's over to here with this non-dy dx. So I'll minus cosine x, and I'll plus, because it's a negative 2xy, so I'll plus 2xy. And that will leave me with, I'll write it small because I need some room, x squared dy dx plus dy dx is equal to 10 minus cosine x plus 2xy. Here, again, you've got two terms with dy dx, so you factor it out, and you have x squared plus 1 is equal to 10 minus cosine x plus 2xy. But I'm going to divide, because I want to get this alone, the dy dx alone. So I'll divide both sides by x squared plus 1, and that will be my final answer right here. Dy dx, and you should rewrite it. It should look like this. On the next line, but I'm out of room. Hold on, I made one mistake. Here. And I'll just erase and start over from here. Let me just do this one more time. I made a mistake with one sign. All right, I moved cosine x, and when I did, I forgot that this was a minus. So this is going to be a minus. So it's not really changing much. But I just got to make sure you have minus x squared plus 1 is equal to 10 minus cosine x plus 2xy, and then minus x squared plus 1. Sorry about that. Now I got this one here from YouTube, Nancy Pye. She's got a lot of good examples, and I like to use her examples just so I'm checking myself like this, because I might make a little mistake. But you might want to go and watch some of her videos on derivatives and the chain rule. All right, I'm going to do one last problem. thought I had one more written for you guys. Oh yeah, this one's a little more. Okay. So this is, I never know what number I'm on. Anyway, so you guys have it in your notes the right way. Make sure you're writing down everything I do. Don't just think that it's on video and you can go to it. Writing it down makes it soak into your brain. You're etching it into your brain. All right, so what I have here is if I say find the derivative with respect to x, okay? So they might write it like this. I'm not gonna call it, wait, hold on. The derivative with respect to x of this whole thing. So in this case, you're gonna take 3y squared, but that's not an x, so you put dy dx, plus now you have the product rule here, because you're being multiplied, so that's going to be plus x squared times 5y to the fourth, because I'm taking the derivative of the second. Don't forget dy dx, plus y squared. This is still all, I'm still doing this. This part right here is all still this little bit. So it's plus y squared. You leave, sorry, y to the fifth. Times 2x, because now I'm taking the derivative of this, minus 4x to the third, because that's power rule, is equal to 20, oh no, sorry, the derivative of 27 is 0, so is equal to 0. Now I'm going to put all my dy's on one side, and that's going to be this and this stay on one side. And then these go to the other side. So let's just do that in one quick step. I'll have 3y squared dy dx plus 5x squared y to the fourth. I'm just making it look prettier. That's this. Dy dx is equal to, and now that's going to be a negative. I'm moving it over here. So it's equal to negative 2y. No, let me write it. Negative 2xy. That doesn't matter, but it looks better. Negative 2xy to the fifth minus 4x to the third. And you factor out your dy dx to leave you with 3y squared plus 5x squared y to the fourth. This side stays alone. And now you isolate dy dx. And you know I'm just going to write that there. And you have 3y squared plus 5x squared y to the fourth. And that's my last example. Make sure if you have any other questions, you reach out to your teacher, and be great.